So welcome everyone uh, to the Additive Manufacturing Open House, which is an initiative jointly by the Barnes Global Advisors and Additive Academy. It's part of our initiative for training, education, and skilling the economy. We're just trying to connect the ecosystem with obviously the limitations we have today with COVID. It's good to connect digitally as well. So we have a short presentation and panel now for all of you, and of course we'd like you to be part of it as well at the end, where you can ask your questions. Please, you can keep sending your questions during the uh, session as well. You can go to the Q&A tab on your right, and you can keep adding your questions. We'll take them up at the end of the session. And so we have today with you uh, from the US, John Barnes, who's the co-founder of the Barnes Global Advisors, Laura, who's also a senior member at their organization. From India, we have three experts who have been in this field for quite a bit of time. I'll definitely go into the introductions later during the panel. We have Mr. Raghunandan, who was part of one of the first service bureaus in the metal space, and he's been in the industry for quite some time now. We have Mr. Vaman Kulkarni, who was the ex-director aerospace and at Honeywell, India, and we also have Dr. Deepa Srinivasan, who's currently the chief engineer at Pratt and Whitney in India, and she has also is associated with a few institutes. So it's great to have all of you here today, and would like to start off with a just as a context setting. I'll just take maybe a 5-minute presentation about the Indian ecosystem at the moment, and what we do as Additive Academy. So I'm just going to share my screen here. Hope everyone can see my screen. So this is just to set the tone in terms of what the market size is like, what are the kind of companies present here. This all obviously is just representational. There may be some brands which are not here. It doesn't mean they're not present in the market, but it's more just to give you an idea of the current scenario of the industry. So as you can see, most of the international brands, the leading ones, are present today in India with their installed bases and their representatives and offices in India. And on the right, you'll see a lot of the homegrown brands, which include some of the service bureaus, machine manufacturers at the FDM and back polymerization level, some of the service providers. So it builds the major companies in the ecosystem. We had done a study back in 2019 where we kept the market value of the Indian AM industry at about $0.6 billion, which is around 4,500 crores. Of course, this includes the installations and the output of this technology. It's the whole ecosystem which is valued at that. Of course, automotive tooling, dyes and molds, jewelry, precision engineering, medical. These are some of the areas where AM is being used in India today at various levels. Of course, it's still at a prototyping or a one-off level at best. In some cases, maybe there is some low batch manufacturing at a remote possibility, but it's more prototyping and one-off parts at the moment. Defense, aerospace is also using the technology. Healthcare, as I said, it's more on the dental side. There's a lot of manufacturing of dental copings and other products, and healthcare, medical devices, and implants. So that's what the industry is like today. And if you look at the split in India, 20%. Of course, this split includes both polymers and metal. We're looking at automotive, which was one of the early starters in India, utilizing this technology for prototyping. I think 20% today is automotive, followed by tooling and engineering, 18%, jewelry, dental and healthcare, which maybe this is numbers from 2019. So I would say healthcare, dental would move up a bit. likewise for government, defense, and aerospace. So this is kind of a scenario which gives you the kind of applications today in India. Metal, again, you can see where there are about close to 100 machines today in India with different brands across, with of course the German organizations like US, SLM leading the race, with other organizations like 3D Systems, Trumpf, Sysma, Concept Laser, Renishaw, and quite a bit of the others from the Asian region as well. Of course, we have a new mover in India now with Intech, which is the first Indian company to manufacture additive manufacturing machine for metal AM machines. So I think that will figure in these statistics as we go ahead. So it's an interesting time to be in India with a growth in various areas. So today, since our main topic is more talking about the training and the education side, would just like to brief everyone about what's the academy and education scenario here. Of course, these are just examples. There are more universities and institutes taking interest and working in this space. So the Indian Institute of Technology centers across India and IISc Bangalore have been at the forefront at AM research along with NIT centers. And of course, just as an example, IISc has set up a AM COE at CPDM, which is the Center for Product Development, and they're building a globally competitive DED system at the moment. So there's a lot of research on that side happening. CSIR, which is the leading research organization, a semi-government organization, they are working on AM and collaborating with Fraunhofer to see how they can adopt and accelerate AM in the country. ARCI, which is the leading material institute and research facility in India, is working on material characterization and other research. Of course, a lot of most of the colleges today are offering AM as electives, but few of the colleges or educational institutes have taken lead are like IIT Bombay, College of Engineering Pune, NIT Warangal, and the National Institute of Electronics, who have dedicated courses, diplomas, or like NIT Warangal, even MTech in additive manufacturing. And many private institutions are conducting academic and research activities. Quickly going through the government initiatives, there are many, but just to pick on few, this is the Atal Tinkering Labs at the grassroots, where 3D printers at a desktop level are being installed across more than 10,000 schools in India. Recently, the MeitY, the Ministry of Electronics and Information Technology, is working on a national policy for AM and setting up a national center for AM, which will really be helpful for growing this technology in the country. And of course, there are various technology grants under various schemes, not specifically AM, have been supporting universities to invest in AM systems and organizations in their research. And of course, opening up of the space sector recently by ISRO and the government has really helped multiple startups spring up, which is leading to adoption of AM for new product development in terms of the delivery vessels and the rocket engines. There's a lot of work happening on those sides, especially companies like Skyroot and Agnikul are taking lead in this. And of course, government and defense organizations in India like ISRO, HAL, DEL, DRDO, etc., have been investing in AM infrastructure and components. So this has been building the foundation for it. New horizons, of course, as I mentioned, local development and manufacturing of industrial AM systems. So Intech Additive Solutions, as I mentioned earlier, and others are on the anvil. So we will see a very exciting ecosystem building there. Local materials and manufacturing. Indomim have taken the lead, and I'm sure many other companies will follow. Of course, India has a large engineering and IT workforce, which I think India can position themselves as a design engineering hub. Look at how they can fit AM into this and other industry 4.0 technologies, which can really help us leapfrog the technology race. And of course, with a large addressable market, AM applications of healthcare and dental are scaling. Indigenization of defense will lead to new product development opportunities. So this is a quick snapshot of what's happening, and that the potential is there for this technology to grow. We've at Indian 3D Printing Network, we've had our own few milestones. We started in 2015 with a trade show in Mumbai, and subsequently we've started a digital online platform in 2017. We've worked on a few of our international alliances from our 2019 point of view, scaled up our trade show and our other outreach activities. We've launched the Additive Academy end of last year, which in partnership with, of course, the Barnes Group Advisors and Purdue University. We're also partnered with ASTM International to bring their training and standards to the Indian subcontinent. So we're trying our best to be a able support system for this industry. So about Additive Academy, it's a training and education initiative. Which is basically for AM training on both polymer and metal technologies with a vendor agnostic viewpoint. I've overrun my time, so I'll just share this with everyone later. But just to give you a quick thing, basically with Additive Academy, we plan to have training programs with courses and customized AM training with focus on both polymer and metal. Support on the full AM process with our team of experts spans from material selection, design through final inspection and regulatory requirements, and a vendor and technology agnostic approach which is very important for this industry to grow, and consulting services and industries specific training. So additive manufacturing is growing, and as it grows, and for it to grow in the right way, there's a lot of skilling and upskilling required, so that we can grow sustainably. So with this, I'd like to hand over to John, so that he can share a bit about how their organization has worked in a similar manner in the US, and how they have achieved skilling the organizations there.
Great. Well, good evening, everybody. It's good to see some familiar. Well, I'm not sure if I'm seeing the familiar faces yet, but I see some familiar names, and I appreciate the opportunity to be with you this morning. Let me quickly figure this out. Enter screen. There we go. Okay, so briefly, Barnes Global Advisors, we've been around. We've been around a long time individually, but we've got a team of 14 seasoned professionals who have very intimate knowledge and awareness of, but probably importantly, all of the forms of additive manufacturing, and in most of those cases, we've put them into use. We have qualified them in aerospace, medical environments. So we can go quite detailed. We can start with strategy and work through a qualification if that's what the need is. And we're probably the only outfit out there that can go from like a consulting engineering project through training and vice versa. We're independent. We're not associated with any of the machine makers. We don't have well, of course we know them all, but we don't. We're not incentivized by any of them. So we will give you our sort of independent assessment of what your requirements dictate in terms of a type of additive, or if additive is even appropriate. We're agnostic to the type of additive technology. We look at things from an engineering perspective. We talk a lot about requirements. And overall, we've got the most experience out there currently. The team has amassed over 130 years in additive manufacturing. When we talk about materials and manufacturing, generally, we're certainly well over 250 years. So we're a seasoned group. We are active in the professional societies. We are contributing to the knowledge base. I'm an adjunct professor at Carnegie Mellon and RMIT University in Australia. I'm also we're a member of America Makes, which is the public-private partnership for additive manufacturing here. We are partners with the AM Hub, which is a public-private partnership in Australia. We're happy to be joined with Additive and the Additive Academy for India. So we try to be we try to think globally. We try to take our experience and use it to help others. So we do some communications for people. Our primary role is in the advising area, and we have training, and so I think we're probably number 2 in the marketplace for additive manufacturing training. We've trained, I'm going to say, somewhere around 1,400 people worldwide at this point. We do have the online certificate that we do with Purdue University. It's 100% online. You can start whenever you want. You can run at your own pace. It's completely video driven. We do on-site workshops, and now we have virtual workshops. And so that has afforded us a lot of flexibility, and those products have gotten better and better. We are a global team. We have the Purdue relationship. We obviously have the Indian 3D Print Network relationship. We also have them in Africa and in Europe. So we have trained people on 6 different continents at this point. Briefly, our team, it is a very experienced group. We're multidisciplinary, from mechanical design all the way through material science, decision science, strategy, process economics, production engineering, etc. So we have a very good team. I pulled this quote out. This is a graduate of the Purdue AM certificate, and I thought this might be germane to the conversation. And in this case, the individual took the course, probably had very little knowledge of additive manufacturing, but it was very intrigued by it. Tyler took the course. He was very inquisitive during the course, and once he was complete with it, he made a business proposition to the company that he worked for. He wasn't hired into doing anything with additive, but he saw an opportunity that they could make some tooling via an additive methodology. He took his learnings from our process economics, business case module, and successfully made a case to his management. And then he became in charge of the printer, and basically his career took a new direction after that. So he was then getting additional training, and was able to communicate effectively to others in the organization why additive was going to make a difference. And I think this is part and parcel with why we like the training aspect, because it's improving individuals, it's improving teams, and it's a way to get people to appreciate what additive is. We do offer the live training that we can do either in person or virtually, is the Designing for AM. That's our core product. It's 20 hours. It covers an essentials element, AM technology and materials, where we cover all of the forms of additive technology and the materials implications, and in some cases design constraints. And then our Design for AM module really takes students through what we call modify for additive approaches versus truly design for additive approaches. And then lastly, the popular, last module is our AM business case and economics. So we run through cost drivers and different ways to think about making a business case with additive. In this course, we do a team-based design activity. So the teams will design a part and describe it. So it's not so much about how good of a design person you are, but we have an assessment, and that's how you graduate the course. Usually it's a lot of fun. Everybody always enjoys it, and it's good work, and you can watch people learn as we go through it. We do offer some specialized courses around powder production, computer tomography, and an advanced AM operator course that we just developed. So these are also available. And I think probably relevant to everybody right now is we started this online AM certificate a little over 2 years ago. And so this was with the idea of being able to reach a lot of people through an online format, which now with the difficult period that we're going through, is in some ways maybe a silver lining is it's a good time to go online and get some additional education while we can't be out and about. So we have this course. The certificate is built on 2 core classes, an AM Essentials and the Technology Materials. And then you have an elective. You can take Design or economics. The honors course then is all 4 courses. So this is 100% online. You can start it tomorrow. You can register through our website. I believe Additive can facilitate that conversation for you. So the first step is probably talk to Additive Academy, and then he'll send you to us. I don't know, Additive, if we can talk about that later, but maybe we want to talk about that.
We can.
Yeah. So it's a very, I would say, successful certificate, and so with this, you know, there's really no prerequisites. I would say that people with a technical background will not have any challenge with it. We have had people with more business background take the course. It is, I will say, quite technical, but it is not a college course. Let's in its intensity. Let's say it is designed for working professionals. We talk about designing for additive, and so we kind of break this up into 2 spheres here, and so we call it MFAM and DFAM. And so MFAM is largely when you have a part that maybe it's a spare part that you really can't do much redesign to. So it largely has been designed to be cast or machined or forged or what have you. MFAM is then what the skills you need to make it work within an additive environment. DFAM, on the other hand, is where you have design flexibility. You've got more opportunity. Maybe it's more of a clean sheet proposition, and so the tactics and the approaches that you use for that will be different. So this is kind of gives you a glimpse into how we view the designing for additive environment. We talk a lot about requirements, and when we walk through this, we won't go through some detail, but you know, it's a process. There's a build layout, support structures, there's design guidelines, process parameters, post-processing, inspection. You know, these are all the considerations, and they have to be taken into account in the design of the additive part. Otherwise, you know, you'll get midway through it and then have difficulty. I would say, you know, our view, we tend to carry a few thought processes through our courses and our conversations. Additive is a sufficiently diverse technology. We talk about machines, we talk about materials, we talk about the digital space, and of course we talk about the people elements of everything. We do employ, we kind of pioneered the approach of looking at additive manufacturing as a maturity model approach. And quite simply, the gray area kind of represents product requirements, and the blue area represents the skills and knowledge in order to be able to hit those. So as your part concept matures or is working in a more demanding environment, your skills and awareness have to be keeping pace. Otherwise, you reach a situation where you've got a very high product requirement, but you don't have the skills necessary to get there. We also split that world up again into the machine, the material, the digital, and the people. So we can kind of give a company or a score on, you know, a readiness kind of approach using that maturity model framework. We get very good comments on our training. People like the course. We have, I'll say, here's again the options for training and designing for AM modules. So we get very good comments with people going through the course. Partly is due to the instructors because they have a lot of experience. I think it's relevant to point out that we have carried out some training in India. We already have some Indian students running through the Purdue certificate program. So, you know, I think this is a great partnership. We're really looking forward to it. We're ready to lean in with Additive. This has been a relationship probably two plus years in the making. I think Additive and I first met at Formnext maybe 3 years ago now, but it seems like forever ago. And here we are. So I think in general, you know, I believe that India is going to be strongly influential in additive manufacturing, and because of its manufacturing prowess and engineering prowess. So we would just like to help people get the skills necessary to take it forward faster.
Yeah, that's great, John. I think it's you know, a great intro into what model you're following there in the US. And we have few experts from the Indian industry today, and of course Laura as well from the US. So we have a few, we have a quick panel with them, have a few questions for them, and they can share their insights as well. So we have Mr. Vaman Kulkarni, who's an industry pioneer with almost 34 years of hands-on experience in the aerospace sector, working on aerospace propulsion systems, mechanical systems, components, and additive manufacturing technology. And he was the director at mechanical systems and components at Honeywell Technology Solutions. And he has worked with some of the biggest names in the industry today, and he's played a key role in Honeywell setting up their AM system facility in India. We have Dr. Deepa Srinivasan, who's the chief engineer at Pratt & Whitney R&D Center, Bangalore, India. And she has over 20 years of experience in developing gas turbine materials and manufacturing technologies, and is a pioneer in the area of metal AM in India. And she has developed several applications for metal laser additive manufacturing as a unique technology enabler for gas turbine component repair and component life extension. She's also adjunct faculty at the IIT Ropar, visiting faculty at Vellore Institute of Technology, and she's a research professor at Welltech University. We have Raghunandan, who's an industrial engineer from Bangalore with more than 24 years of experience in various verticals like steel, graphite, specialized surface finishing, and metal additive manufacturing. He brings with him expertise of 7 years of youth in the metal AM space. He has previously headed operations at Intech Additive Solutions and exclusively handled aerospace and defense business. We have John, of course, who has a 25-plus-year career in product development and aerospace with Honeywell, Lockheed Martin, Skunk Works, Australia's CSIRO, and Arconic. He's of course the founder of the Barnes Global Advisors. And we have Laura from their organization as well. She was the head of technology at GK in aerospace, and she was required to affect technological change in large organizations. And this includes translating technical roadmaps into strategic business visions, vice versa, building business cases, securing capital, and operating, protecting, and exploring intellectual property. She also brings a lot of expertise of laser wire deposition for titanium aerostructures. And she has been part of a lot of partnerships in that area. So we have a interesting expert panel. And to start with, I just have a question to our panel from India in terms of you are aware of what the scenario in India is today in terms of the industry and in terms of the training. What gaps do you see today which need to be addressed to kind of bridge that gap between academia and the industry, and how can this combine to kind of accelerate AM further today? So I just like your insights on this before we get into the panel. So maybe Dr. Deepa can start, and we can move on to other experts.
Sure. Good evening, everybody. Thanks, Aditya, for a nice overview on AM market in India. And John, enjoyed seeing the training that you're offering in the course with Purdue. So let me just understand the question. Is the gap in terms of translation of technology, or is it in terms of training you're asking?
The gap in terms of training. And how between how fast the industry is moving, and of course the academia and the educational system.
I think this one particular technology is so driven by the industry. So unlike typical courses in mechanical engineering or aerospace or whatever manufacturing technologies, here literally speaking, I think the industry has adopted it by an online training, by just taking people and training them on the job. So at least in India, I think the academia is only catching up in the last 3 to 4 years. And you gave some very good examples of CPDM at IISc. I think practically out of 24 IITs, I think about 6 or 7 of them at least have laser powder bed fusion machines. And then the national labs are catching up, and more. I saw a participant, Dr. Shivaram Krishna, has just written in the chat that they are also a center of excellence. And I know a lot of governments are putting centers of excellence, CSIR labs and so on. But In terms of training, I think formal trained people, it's few and far between still now. So I know the Tatas are starting and specific skill management on Industry 4.0, where additive will be a big chunk of it, but it's not specific to additive, it's on I 4.0. They were going to start a big initiative on IIS, Indian Institute of Skill Management for Industry 4.0. You probably know that. Other than that, there is basic mechanical engineer, basic metallurgy. I think this is one particular industry where you need a lot of metallurgical expertise all over the world, but particularly also in India, unlike other manufacturing disciplines. So it is still on the anvil. I will not say we are taking people with, say, a degree or a master's, even to go back to foundry technology. We look for people in castings and at least in castings with an MTech degree in casting technology. That's not so the case in additive yet. So I'll leave it for the other panelists, and maybe if needed,
Sure.
come back on this.
Sure. Anything, Mr. Kulkarni or Raghu, you would like to add to this?
Yeah, I will just take 2 minutes to add to what Deepa told. Of course, yourself and John had given a good overview. This is more from my practical experience, what I have seen. Typically, everybody thinks that 3D printing or additive manufacturing means once we have a 3D model, it can just be printed. It's true to a large extent, but still it is a technology. So there is a lot of things which needs to be systematically studied as part of this technology development. When we were in Honeywell, when we set up this infrastructure, our success rate or the yield was only about 25%, which means that almost out of 4 parts, we used to succeed only printing 1 part. And every day we have a new design coming in to make best use of this technology. We have the other challenges which come in. So whether it is support related or it is the thermal expansions which happens in this, I'm talking more about the process piece of it. So it's still a technology which needs to be understood by the students who wants to get into this. So I feel there is a lot of interaction which will be needed between the industries which provide this as a service and the education institutions. So a theoretical knowledge of going through this will expose you, but practical knowledge is a must. The second piece of is the design for additive manufacturing. I think John's chart very clearly brought it out. We see a lot of advantages which everybody talks about additive manufacturing. If you had to get best benefit of additive in either whether it is a new product development or even if you are replacing an existing part or an assembly, we have to understand all those design for additive manufacturing intricacies which are required. Whether it is related to the weight reduction or it is getting the additional performance benefits what additive can provide, or it could be in terms of reducing the cost of the overall part itself. So unless you go through that design for additive manufacturing, and it's a multifunctional area which is there is a DFAM. When it comes to performance, it could be the computational fluid dynamics or the heat transfer or thermodynamics which is involved, and a lot of analysis tools which are available, and we need to be aware of how we can use that. And similarly, the other additive related things in terms of support generation and what is the best way to build a part, how we can minimize the wastages, which are all additive process related activities. And nowadays, simulation is playing a big role in this area, and there are quite a few simulation tools which help us in finalizing those designs. So that's another design for additive which also needs to be systematically studied. I think these trainings will definitely help the people to be better prepared when they get into the industry.
Yeah, I think that's a valid point as well, apart from what Dr. Deepa added as well. And Raghu, would like to add anything to this from your industrial experience of working with a service bureau, which you brought up from the start? You're on mute, Raghu.
Yeah, good evening, everybody. It's a pleasure to connect with all of you on this Thursday evening and Thursday. Yeah, just to add to a very interesting introduction given by Aditya and John, and also deep, insights on the technology given by Dr. Deepa Srinivasan and Mr. Vaman Kulkarni. Just quickly, I would like to add one point which is very important in this technology. The identification of the right component. So that makes a lot of difference, whether, right from, suitability of the technology and we're working out a proper business case analysis. So part identification and business case ROI is a very important case to be considered for the adoption of this technology. And it's very important people are very aware of this skill sets in both these areas before they start getting additive manufacturing on the field. So this was just one point I wanted to quickly add.
No, I think it's a great practical point, which you've asked, and quickly moving on from here, these are valid inputs, and US of course has been kind of a leader in adoption and implementation of AM across. So are there any points you would like to share, Laura and John, that which we could translate to kind of reduce the learning curve or accelerate AM here in India? Are there any key points, maybe 2 to 3 points you could share, which you feel are critical for us to adopt at this point of time?
Looks like I'm on mute first, so I'll go first. I really appreciate all the points that were just made. So some of the things that we talk about, a lot of people we've seen where they come to us after they bought a machine and they're a little confused about how to run it and they're having issues with it, those types of things. And they don't exactly know what parts to make on it and they don't quite know the business case. So I think one thing that we really, really encourage is step 1, educate. Step 2, buy and launch your AM journey. And whether that's individually or as a company. And I think the other bit that's so important is it's not just about the technology people understanding the comprehensive end-to-end nature from part selection and raw material all the way down to finished processing. The engineers need to understand that, but so do the business people, so do the leaders of the company, so do the buyers, right? Because to really broadly adopt AM, an entire business needs to understand it. And there's quite a bit of the business factors as well as the technology factors that are different. The business models for machining and removing material are different than adding material. So those people need to understand that as well. And we've started to see that particularly with the large companies. So big oil and gas companies that now have additive going, now they're going, okay, whoa, we need to train the masses. And that is what's going to unlock the next step of AM adoption. So it doesn't really matter whether you're a small company and you've got that common language, or you're a very large company and you have that common language, but having that broad, comprehensive understanding is a really good launching point for anybody in their AM journey.
And I would echo, all the points that were made previously were pretty spot on. You really, if you think about it, you would design for manufacturing product, and so we have evolved a lot of products to be good cast parts or to be good forged parts. So just taking that same shape and then throwing it at an additive manufacturing process, it doesn't make sense that it should be successful, immediately. Now, there are certainly cases where, they were never great products for those processes, but we may do. And so those are great candidates. That's where we talk about MFAM a lot, but where we can get into a unitization mode, and, consolidating parts and making, a single part as opposed to many multiple parts. But then, what we're seeing more broadly is that additive is very diverse today. So it's a family of technologies, and so we try to talk to people about an additive way of thinking about it. And quite simply, we break it down into, if you can describe how you generate a layer, how you make a layer, what your material feedstock looks like, and what kind of energy you need to apply to it. You can describe any additive process. And so we try to make this very simple because we don't know what people are going to invent next. There's a lot of additive processes out there which are now getting to be hybrids of other additive techniques. So the design, I think personally for engineers, the next 20 years are going to be fantastic. This is an engineer's technology. It's actually good for people, even though it looks to be a very hands-off technology. It requires a lot of intellect to do it correctly, and it requires a lot of teamwork to do it correctly. And if the teamwork doesn't use the same language, it's very inefficient. It's very difficult. So metallurgists are going to love this technology. Polymerists, material scientists are going to enjoy this technology, but they have to talk to their design friends, and the structural engineers have to understand what's going on. So that's why I like it. I think it requires people to work together to get a good outcome. I think gone are the days where we come up with an idea and then throw it over the wall and it's somebody else's problem. So this one kind of confronts it right up front.
One other thing that I'll add is, as much as we love additive manufacturing, it shouldn't be special. What we've seen a lot of is someone gets an AM machine and now they have an AM hammer, so everything looks like an AM nail. Additive manufacturing from a total manufacturing process should be a tool in the toolbox, and it's just engineers and manufacturing engineers should be using it when appropriate and understanding the capabilities. But there's plenty of products that should be made with traditional manufacturing. A better business case and perfectly good from a performance standpoint. So to Raghu's point, understanding that, but also respecting the fact that AM
I think we lost you for like the last 10 seconds.
I saw that. It's okay. I was done. Thank you.
Okay. Great. So this is a great discussion. Unless any of you, Dr. Deepa, Mr. Kulkarni, Raghu, you want to add to what John and Laura said, I just want to take a couple of questions from the people. So if anything, would you like to add anything, Dr. Deepa?
No problem. I think there are some questions, so I'd like
exactly.
to answer some of those. So.
Yeah, so there's a question on how are other technologies like cold spray and repair technologies collaborating with powder bed fusion and binder jet technologies? Are there any efforts that are trying to close the gaps? This is by Balaji, who's asking about how are other technologies like cold spray and repair technologies collaborating with power bed fusion and binder jet technologies? Are there any efforts that are trying to close the gaps? So.
Sure, I can take that. Yeah, sure, because I've worked quite a lot on cold spray. I'm not sure, what Balaji means by trying to close the gaps, but I think cold spray is still, it's a completely different mechanism. So people are trying to say it's another additive. I don't think the ASTM F42 committee has yet taken it in the true definition of additive. Binder jet, of course, is a part of additive because the definition is that you need inputs from a CAD or a geometry to be sliced into layers and be digitally, translated into the machine. So I think I think Mr. Balaji has actually taken a lot of answers to each of these. So cold spray is used for repair and refurbishment of several sectors in oil and gas, in heavy earth moving kind of equipment and so on. Cold spray is widely used there, whereas powder bed fusion, the footprint is not something as yet conducive to large scale manufacturing. Direct energy deposition, yes, and binder jet is still, I know it's still being, there are lots of things being sought out in terms of the difficulties in binder jet, especially for slightly bigger components like 100 by 100, millimeters. So I don't think each one has its pros and cons in terms of speed, in terms of precision, net shape forming, productivity and so on. So I don't think each of them is going to, they'll be complementing each other. And I would like to add to Raghunandan's point about you need to know your product, what you need to manufacture with additive, since if it is an end user, if it is an academic institution, in terms of there's plenty of scope actually. Since this particular thing is with respect to John and Laura's combined initiative together with Aditya's Additive Academy, I think there's so much to be, there's so much of opportunity in the academia, to be honest, to complement, because there's so much of science to be learned, and industry has actually jumped into it without truly knowing. So, for example, we don't know the thermal stability of things, we don't know the structural integrity of these in the actual functioning. And so on and so forth. So I don't know if that answers your question, but yeah, but I will leave it at that. I love the others.
Any other panelists? Any of the other panelists would like to take that, or do we move to another question?
The only thing I'd add to that is that we had a discussion about this with some cold spray experts a couple of weeks ago, and I think the comments are right, but everything's relatively early, so just the notion of what is good feedstock, because if you think about what's required for binder jetting to work is sintering. What's required for powder bed fusion to work is actually a weld pool, and what's required for cold spray to work is because it's a solid state process. And so the requirements in the powder should be quite different, and entry-level discussions into how to make those processes better and more robust, and even to the point of ASTM jumped in with the F42 committee, and those definitions are not holding up. So do we ignore something because there's not a good definition for it? Probably not. We will progress and we will move on, and eventually the committees will catch up. So I think innovation moves at a very rapid pace.
There's another question on how to kickstart a career in metal AM with knowledge in material extrusion or FPM.
Well, I'll jump in just with it's a very common approach. Even the bigger companies like Ford, would buy the desktop FDM style printers, and it's very useful in terms of getting engineers to think in terms of layers and to at least start thinking additively. But then there has to be, that next jump, because what it takes to get metals to work, typically they're more expensive pieces of equipment. They're more, usually going into a higher requirement space. So I think it's taking the thinking of additive and then applying some metallurgy, applying some structural mechanics to it. So naturally we would promote taking the Purdue course, but doing a lot of reading and getting familiar with what's different with a powder bed fusion. Quite simply, can you describe powder bed fusion, using an FDM as a starting spot?
I just want to add to what John told, because we had these small desktop FDM printers in Annual, but the purpose is different. The purpose is mainly to do few design iterations very quickly, look at visually the parts, look at if there are going to be any assembly challenges, or if you quickly want to take a product for any of the customer demos. It's a non-functional part, but it can give you that physical feel of the part. But when you come to the powder bed fusion or the metal additive manufacturing, it is different, but the basic definition of additive remains the same. But there are other technologies which are involved when you start looking at the powder and you're trying to sinter that, the thermal deformations which could be there, the process parameters are different, but it helps to have a feel of that and then get into the next level.
Yeah, I think that helps to answer that. And there's one more question from. I'll just take maybe a couple of questions quickly. And Dr. Shivaramakrishnan is asking: Is there any plasma arc based metal AM process, and can we use it in the aerospace technology?
I love the directed energy conversation. So basically, every welding process, there is an AM equivalent of directed energy for that. Maturity of them are at a significantly different levels. So with respect to aerospace, there are several companies that are using plasma, and there's others that are using arc processes. There is Norsk Titanium that has parts flying on the Boeing 787, some floor grid components in titanium. And so that is definitely an aerospace application, flying application. There are several other flying DED applications. Actually, Kevin Slattery and our team helped qualify the first one on F-15 on a pylon rib, I don't know, 20 some years ago. So the struggle with some of the aerospace technologies are the business case usually comes in on titanium and nickel alloys because those are hard to machine. But that also means those tend to be critical components. So it is not an easy qualification path. It's certainly being pursued. It's certainly being done. The team that I stood up down at Oak Ridge National Labs is doing that for laser wire for aerostructures. So there's lots of work going on around the world. But I would say for aerospace, it's certainly it's a very rigorous path to be putting any of those technologies onto an airplane.
Aditya, I think you're muted.
So no, I wanted to check with you, Dr. Deepa, if you want to add to anything on this plasma arc question with your expertise of using different hybrid technologies. Would you like to add anything or?
Yeah, sure. Actually, I'll go back to the the question on the. I'll go back and then come to this on the cold spray itself. I don't think there's, I don't know if Mr. Balaji is still there. I don't think you need to call anything, you can use cold spray is very, very actively used in a lot of repair applications, qualified in stationary parts, helicopter housing. Certainly the AFRL and teams have done a lot of for magnesium and titanium housings. And we've also used it for many stationary parts in the oil and gas. So whether you're calling it by the name additive or not, it doesn't matter. It has been used extensively for repair. And to add to Laura's point, you just need to get the qualifications right with due diligence, depending on the components. I can definitely tell from my experience, wire arc, and I'll go to the next question on the plasma arc. Wire arc, additive manufacturing, like she rightly said, along with DED, direct energy deposition, there have been a lot of examples of titanium-based materials, both rotating as well as stationary components that OEMs have qualified with partnership with major players for the aerospace sector. So definitely, these have already been established about in the last 5 years, I would say.
Great, thank you. So I'll just take one last question, and then of course we have a networking time after this. So anyone else, if you had questions left, we can reach out to any of the panel for say 10-15 minutes after this, and you can take it. So Dr. Shivaramakrishnan, yeah, about partnering with Additive Academy, I think we can connect offline as well post the session, and we can connect with you and see how we can work with you. Of course, we can look at in terms of curriculum development, or is there any support needed in terms of the process at the university. We can look at these things as well as a group. So we'll reach out to you after the session. So thanks a lot to